Hello everyone, welcome back again. So let's continue with our multiple regression model, and today we'll be talking about the specification bias in the multiple regression model. So I hope you remember the assumptions of the model. In those assumptions we had discussed about two extra assumptions that were different from your simple linear regression model. Okay, so we had discussed the ninth assumption, so we'll talk about the 10th assumption, that is uh, it says that the model should be correctly specified, that is, that there should be no specification bias or specification error. So, no specification bias, that is the 10th assumption, okay, of the model. And let's try to see what this means. Okay, so let us assume that the true model looks like this. So, it's a multiple regression model, and it looks like it is looking like this. Okay, but suppose we disregard, or somewhere down the line we just forget to mention it, or we just skip mentioning, or we disregard your FLR. So you know these terms. This is basically your child mortality, which is a function of your TGNP, is your per capita gross national product, gross national product, and FLR is female literacy literacy rate. So we are trying to regress the child mortality variable on two independent variables, which are per capita gross national product and female literacy rate. So how these variables are impacting the child mortality, that is being trying to be captured. Okay. So suppose this is the true model, or how the model should be, but somewhere we disregard FLR and estimate the following regression. So instead of regressing this equation that is given over here, we regress this equation. So we are not including your FLR variable in the model. So the model looks like something this. So yi is equal to alpha 1 plus alpha 2 x2i plus u1i. Okay. So the coefficients are different in both the models, because we'll see why we have done this. Okay. So specification error implies that it consists of omitting the variable, or a variable. This should be a variable. So in this case, it is x3. In our example, it is x3 variable, which is your female literacy rate. Okay, this one, right? So in the case of specification error, the error is about not including a particular variable in the model where it should have been included. Okay. So alpha 2 provides an unbiased estimate of the true impact of PGNP given by the beta 2 model. So in by this model, so instead of using this model, we are using this model to regress child mortality on your PGNP, because we have not included FLR here. So alpha 2 is giving is what? It is giving an unbiased estimate of the true impact of PGNP. Okay, given in the beta 2 model. So in the real model, here, beta 2 was trying to capture the impact of PGNP on child mortality. So in this model, that is being done by your alpha 2 coefficient. Okay. So we know that the coefficients of your multiple regression model are blue, right? We have read this property. So it is an unbiased estimate of the impact of PGNP. So this means that, or does this imply that the expected value of alpha 2 hat? So we'll try to estimate alpha 2 using a sample, and we'll get alpha 2 hat values. So for is alpha 2 hat an unbiased estimator of your beta 2, that is of the coefficient in the real model, or the model that should have been. So Is this the case? So the thing that is being, or the question that develops here is that if we estimate child mortality using this model instead of this model, so my alpha 2 hat will, or the expected value of alpha 2 hat, will it give me the same value of the coefficient at as it was supposed to be found in the actual regression function? Or in simple words, is the expected alpha 2 hat value is equal to beta 2 hat. So if I remove this variable, will these two coefficients be same? The coefficient alpha 2 or the expected value of alpha 2 hat will be same as beta 2 hat or not? Or is the variation in child mortality due to PGNP is same as the variation in child mortality in this model, right, where we have not included FLR? So that is being discussed here. So where alpha 2 hat is the estimated value of alpha 2. So will the coefficient of PGNP provide an unbiased estimate of the true impact of PGNP on CM, knowing that we have omitted the variable x3 from the model? So this is the question. So what is the answer to this question? So the answer is no. The expected value of alpha 1 hat, sorry, alpha 2 hat, that is the notation used, right? Alpha 2 hat is not equal to the value of the coefficient beta 2. They are not giving us the same estimates. Okay, why? Because so this answer this answer is basically received using data. So if you have a data set, right, and if you take both of these two models and use these two models and use the same data set to regress a child mortality on your PGNP and the other variables, so you'll find practically the results that you get, they will be that the coefficients will be different in both the models, both the regression models. The standard errors are different, the intercept values are different, and the R square values are also different. So your alpha 2 hat expected value will not be equal to beta 2. This is the property that we understand using data set on both the models. So we get to know that if I omit a variable, or if there's a specification bias, and the resulting regression equation that I use, because of the bias, they will not provide the same estimates, both the equations, the equation that should have been used and the equation that is actually used. So all the values, say the coefficient, the standard errors, the intercepts, the R square values will be different for both the models. So there, that is why we assume that there should be no specification bias, because it will totally change the relationship between the independent and the dependent variable, and we'll get different coefficient and we'll have a different interpretation of the entire situation or the regression equation. So that is why this is important, that we make this assumption of no specification bias. So this was about your specification bias and the 10th assumption of your multiple regression model, right? So this was all for this video. A few more videos remain in this topic, so we'll cover them soon. Till then, take care.